to be a solution in which pH do not change significantly when a small amount of acid and alkalis are added. Okay, that is buffer. Okay, and if in that case, okay, we always use buffer solution to keep the pH constant. Okay, we tend to use the buffer solution to keep it constant. Yeah. How do we get buffer solutions? There are two types of buffer solution. It's either the mixture of weak acid and its salt. One of the example is ethanoic acid and sodium ethanoate. Okay. Or we can also use mixture of weak base and its salt. For example, ammonia and ammonium chloride. Okay, there are two types. Okay, but they have their own pH range. Like for example, of course, if you are using ethanoic acid and sodium ethanoate, the pH is going to be ranging from 4 to 7. Okay, because it's a weak acid. Okay, of course, if you are using ammonia and ammonium chloride, the pH will be close to 11, I think. Yeah, because ammonia is pH around 11. Okay, it's weak. Okay, weak. Maybe 9. Yeah, so near to that. So that is going to be a certain range. Okay, so of course, when we have, let's say, for example, let's say you mix, and then the pH was 5, for example, for this, and you mix, and let's say the pH is 9. Okay, once you get that pH, let's say if I'm going to add let's say ACL, a small amount of ACL into that, will the pH change to become 4? The answer is no. Okay, if I add small amount of, let's say, ACL here, will the pH of 9 change maybe to 8? The answer is no. Okay, that is the function of buffer solution. Okay, because they try to reduce or resist the change. Okay, so what we are going to learn over here is we are going to find out how buffer solution actually resists the pH. Okay, so here we will go through this together. Okay, you can see buffer solutions. Some of it I have already discussed earlier with you, but you can see here they say that, okay, ethanoic acid is a weak acid, so it stays mostly in this form. Okay, why? Because the dissociation, okay, the dissociation of weak acid is quite low. Okay, so they do not give you a lot of H plus, they do not give you a lot of ethanoic ion, so they tend to stay in unionized form. Okay, but when we are using, okay, acidic buffer, yeah, you must actually use together with the salt of the weak acid. The salt of the weak acid that we are going to use is sodium ethanoate. But do remember, sodium ethanoate is fully ionized in aqueous solution. This one we have discussed earlier. So it means that they do not stay in this form. They like to stay in what form? They like to stay in this form. So it means there is a lot of ethanoic ion. Okay, there's a lot of ethanoic ion. So now, okay, let's say using this buffer, I'm trying to, let's say, add ACL. Okay, if I add ACL into this buffer, okay, having these two over there, and I'm adding H plus. Okay, so here an increase in hydrogen ion concentration supposed to lower the pH of the water. Okay, but okay, when H plus ions are added in buffer solution, what happens? Okay, so that is very important. What happens? So here I'm rewriting this equation again. Okay, give me time, I'll rewrite. Okay, while waiting for me, you can always read a bit. Okay, now, so what happens when I add H plus? Okay, when H plus is added, okay, you can see the position of the equilibrium. When we talk about position of the equilibrium, we are interested with the reversible reaction. So we are interested with reaction number 1, yeah, not reaction number 2. Okay, so the reversible reaction, okay, the H plus, okay, will shift the position of the equilibrium to the left. Okay, Charlton, can you tell me why the position of the equilibrium is shifted to the left? What principle do we use over here?
Because the H plus concentration increase.
Okay, what principle is this?
Le Chatelier.
Yes, okay, Le Chatelier's principle, LCP principle. Okay, whenever there is a change in something that is in equilibrium, okay, the system will try to resist the change by trying to adjust or eliminate the change. In this case, H plus is being increased over here. So the position of the equilibrium is going to be shifted to the left. Now, when this position of the equilibrium shifted to the left, okay, what we can see is, yeah, of course, H plus. Now our problem is solved. Why? H plus has been removed. Okay, H plus has been removed. Okay, why? Because the H plus has been removed to give you CH3 COOH. Now, Victoria, only one of the problem is solved over here, which is we remove the the H plus. But what can you say about the concentration of CH3COO minus and concentration of CH3COOH?
The CH3COO minus remains the same, yeah.
Are you sure? No, let's actually focus on equation 1. When the position of the equilibrium shifted to the left, what happened to the concentration of CH3COO minus generally?
Oh, it decreases.
Yes, it decreases, right? Then what happens to the concentration of CH3COOH?
It increases.
It increases. Now, there are changes that are happening over here. Okay, there are changes that are happening over here. So, will there be like automatically everything is going to be the same? The answer is no. Okay, so if you just look at it, no. Okay, because now that's the time the number 2 will start to come in. Okay, the equation number 2 will start to come in. Why? Okay, because, okay, please take note that the large reserve supply, this is going to be the large reserve supply, because earlier I do not have a lot of CH3COO minus. Okay, but please do take note that small amount of CH3COO minus is also being reduced. Even earlier was small and now is being reduced. Okay, now that reduction, will they give you a lot of changes or significant change in the concentration? The answer is no. Why there is no significant change? Because the large concentration of these ions from here, okay, this ion here, whatever that is changed related to this ion will be compensated by this concentration. It means just imagine there's too much, okay, too much of a CH3COO minus. A small decrease will not actually give you a significant decrease over that. For example, just imagine that you have 10 million IDR and suddenly 1,000 rupiah is missing. Okay, 10 million IDR and then 1,000 rupiah is missing. Will you notice the missing money? Most likely no. Okay, most likely no, because it's not significant compared to the big amount. Okay, so that is actually what is going to happen. Even though there is decrease, it's going to be it's going to be compensated by that large reserve of ethanoic ion. And then how about I do have increase in ethanoic acid? What will happen to that? Okay, you also take note that, okay, the large reserve supply of ethanoic acid. Can you tell me where do you have the large reserve supply of ethanoic acid, Gabriela Nicole? Is it from equation 1 or equation 2?
Equation 1.
Yes, this one is going to come from equation 1 because equation 1, they do not dissolve a lot to give you H plus and CH3 COO minus. So they have a lot of ethanoic acid. So if let's say a small amount increase, okay, a small increase in the concentration of ethanoic acid, will it give you a significant increase compared to the earlier one? Definitely no. It's the same analogy if I use, if you have 10 million and suddenly someone gave you money and put 1,000 rupiah, will you notice the increase? Most likely no. Okay, it's most likely no. So here, okay, it ensures that the concentration do not change significantly. So if you look at overall, it looks like even though H plus has been removed, even though the position of the equilibrium has been shifted to the left to remove the H plus, the concentration and everything, they remain the same. Okay, they remain the same. Therefore, we say that pH do not change significantly. Okay, so everything remains the same. So nothing changed. Okay, so the pH remains constant. So let's actually look at, okay, how do we use this system again when it comes to hydroxide. Okay, so we use the same system. Okay, so let me erase here. Hold on. Okay, this one is aqueous. Okay, so here, okay, let me actually write down again. So here, in an increase of hydroxide ion concentration, okay, supposed to increase the pH of the water, but when OH ions are added in this buffer solution, what will happen? Yeah, so OH minus being added. Okay, so the added OH minus ion, okay, they will combine with something. So what will they combine with? Okay, so they will combine, okay, with the H plus. Okay, they will combine with the H plus. Okay, so the H plus that you have over here, okay, they will be combined with the OH minus. But Jody, I want to know what happens to the position of the equilibrium now.
One H plus decreases.
Yes, because the OH is being added, of course, the H plus is going to react with the OH minus, so the H plus will decrease, right? So what happens now?
To the right.
Yeah, you can see the position of the equilibrium is shifted to the right. Okay, so here, okay, they will be shifted to the right. Okay, so you can actually read through. Okay, they are shifted to the right. Now, so the CH3COOH molecule ionized to form more H plus. Okay, and then the ion, okay, until the equilibrium is re-established. So in this case, what had happened? You have successfully eliminated the OH minus. Okay, that one problem is solved. But now the problem is you are decreasing the concentration of CH3COOH. Okay, this one it's shifted to the right. So this is going to be decreased, and you are going to actually increase the concentration of this. Okay, so now, okay, what happens? Okay, how do we actually make sure that whatever that is actually changed over here do not actually affect the others? Okay, so here the large supply, okay, of this, okay, it means this one, even though earlier, okay, we decreased this, but because it's large of reserve supply, the decrease is considered to be insignificant. Yeah, so that is actually like similar with what we have done earlier. And then how do you compensate this one? Okay, so this one, the large supply that comes from equation number 2. This large supply, okay, they will ensure that the concentration of this ion, even though it's actually increasing, they will ensure that the change doesn't actually change significantly. So therefore, the pH do not change significantly. So I hope you understand this. So can we actually sum